top here. We're just going to do general graphs just to show you guys what these look like. But these should all be in that format, a, b to the x. Okay. Now, once you're there, I've got my first equation, and I know it doesn't look like a, b to the x, but I'm going to rewrite this just real quick. So if I just have 2 to the x, this is all done for us just so you guys can see what this looks like, but 2 to the x, it would really be like 1 times 2 to the x. So if you do have something that's just a single number to the x power, that's what's going on there. Okay, now, this is maybe a little bit more of elaborate of a table than I would have put together, but this is a little table. They made up the x values. They did -4, 3, 2, 1, and then 0, 1, 2, 3, just so you guys can see it. And then that middle column, they're plugging it into 2 to the x. So the exponent is that x value. And then they're showing the y value, kind of how they developed that, and they graphed it for you to the side so you can see. The major point I want to make to you here, if you put in 0, anything to the 0 power is 1. So 0, 1, 1, if I plug in 2 to the first is 2. If I plug in 2, 2 squared is 4. These numbers are nice, decent numbers. On this side, this is where it gets kind of tricky for people. If you're plugging in a negative number here, it's not a negative value. Because what happens if I do a negative exponent, like 2 to the -1, it's 1 over 2. Or like if we thought about our negative exponent properties, like I'm just like putting this over 1, move it and lose it. If I do 2 to the -2, right, it's 1 over 2 squared, which is where they're getting the 1/4. If I do 2 to the -3, it's 1 over 2 to the 3rd. That's where they're getting the 1. I'm off the screen, sorry. That's where they're getting the 1/8. So these are just teeny, teeny, tiny fractions, and as that exponent gets more and more negative, the fraction would just get smaller, 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 but it never becomes negative. It's just a teeny, tiny fraction. So that's what creates the shape of the graph here, and we're just getting closer and closer to 0, but we don't actually touch it, and we don't ever become negative when we're doing this graph. All right, so the x-axis, and I've got a definition for this down below, is actually going to be almost like a boundary line, like the graph is going to get really close to that, but it's never going to touch it, never going to go over it. And then all they did at the graph is actually plotted those points. And if you guys get like a weird, like there's decimals there, just kind of estimate where it's at on the graph. It doesn't have to be perfect if you're graphing one of these today. But if you got a nice number and you can plot it, make sure you're on the right point. But if it's a decimal, just kind of do your best to estimate. And then I'm just going to ask, what do you guys think for the domain here? Like as I go left and right, what are my possible x values going to be for this graph that you're looking at? Right? It's kind of J shape. What do you think for your x values? Do what? Like, no, I mean like what would my domain be? Like as I go left and right, it's all connected, right? What do you think? Yeah, this goes, it gets real close, but it goes to the left forever, right? This goes up really fast, but it does go to the right forever. Every single one of these graphs today, tomorrow, -infinity to infinity, or if you want to write that all real numbers, if you like that better. And it's going to cover the entire x-axis. There's no restriction. I can plug in anything for x. It's not going to cause any kind of a problem in that exponent. So -infinity to infinity. Okay, now, remember I told you, we're never actually going to go negative. We're never going to actually equal 0. These fractions, as your negative exponent gets smaller and smaller, just gets tinier and tinier fraction. So I don't actually touch 0. So when you do the range, you don't touch any part of the graph till you hop over the x-axis. So you don't use a bracket here. We're going to use a parenthesis because you're not actually going to ever become 0. So we're going to start just above 0. And then this points up forever, so you're going to go to infinity for your range. So just hopping over that x-axis, and then we're going to go to infinity. All right, and then this just says, does the graph ever go over the x-axis? And I would tell you no. You can plug in some huge number. Like if I have y equals 2 to the x, and let's say I plugged in, I don't know, let's say x was -10. I'd have 2 to the -10th which would be, 1 over 2 to the 10th, which is just some tiny, like if I do this in my calculator, 1 over 2 to the 10th, just some super tiny fraction. It doesn't even want to do the dex. It's a negative zeros in front of it. It's just a teeny, teeny, tiny number. This is not negative. It's just a super tiny fraction. It's never going to be negative. It's just a super tiny fraction. So you will never go over the x-axis. I could plug in like 2 to the 100th power. It'll still be 1 over that, and it's not going to ever be negative. It's not actually going to be 0. So it's not going to ever go over the x-axis. And it actually has a formal name, and that's what's right underneath here. So a line that the graph approaches but doesn't touch or doesn't go over is called an asymptote. So that's all this says. A line the graph approaches, never touches, never goes over it. So we're going to get really close to that x-axis, but we're not going to touch it, not going to go over it. All these graphs will have an asymptote as we're working with the exponential models here. Now, just a general shape for each one of these to show you guys. If you have growth, that's what we just actually looked at. It's just kind of like a little J shape, but it starts small and then it gets big really quick, really fast. If you have decay, we're going to do that next, and we're actually going to do this one by hand here. Decay starts really big and gets really small really fast. So they're kind of almost flipped over from each other. And the neither category, neither happens when A is negative in your equation. And that can actually look two different ways, but both point down. So either one of these would be considered a neither if it's pointed down. So it can kind of go down from left to right, or it can kind of go down backwards, if that makes sense. So growth has to go up from left to right, decay goes down from left to right, and then when the A value is negative, it's going to turn the entire graph to go down. So we're going to just sketch some pictures of these today, but I'm going to have you guys look at your calculator to help you get some points a little quicker. Okay, so very first question we're going to graph, and I'm just going to have you guys make a table. No big deal. We're going to graph y equals 36 times 1/2 to the x. Okay, should this be growth, decay, or neither one? Do you guys remember from yesterday how to tell? This is decay, right? Well, okay, so decay. It's based on that b value. Decay happens if that b value is between 0 and 1. All right, so decay is if that b value here's a half. Okay, now, I'm going to show you a little cheat on your calculator, make this hopefully easier to do. So, if you want to get, we're going to make a table, right? And I could plug these numbers in by hand, but easiest thing I can tell you to do, I usually just do like -2, -1, 0, 1, 2. Just if you do those 5 numbers, couple negative, couple positive, and 0, that is going to give you a really good idea of the shape of the graph. Okay, now, to make this process, instead of plugging this in by hand, which you can do if you want to, you could do like 36 times 1/2, and then take it to the -2 power. Do that on your calculator if you want to. You would get 144, and we could just keep repeating that, plugging those numbers in. Or, I'm just going to show you guys a little cheat here. If you hit your y equals button, it's in that upper left, and you might have something in here because somebody maybe used it last period if you're borrowing one of mine. But just in your y equals, just the very first one, if you just type, I'm going to type 36, and then in parentheses, you can do 1 divided by 2, or you could do 0.5. I'm just going to do 0.5 there. And then use the little caret button. And your exponent, remember, you have to use the x key. It's next to that alpha key there to get your exponent to be a variable. And then once you do that, so just y equals, type in your equation, and then just hit second and the graph button, and it will give you a table for the graph. And so instead of plugging those by hand, you can just kind of scroll up and down here. Like I can see right here, and I don't know how well this is showing up on the screen right now, but I can see right here, like at -1, my y value is 72. At 0, my y value is 36. At 1, it's 18. At 2, it's 9. I could even, if you wanted to write down a couple more, like at 3, it's 4.5. At 2, it's 2.25. And I'm just literally copying that from the table from the graph. So all you got to do just y equals, type in your equation, and then hit second graph. That will give you the table. If you guys don't know this, if you want to ever get out of a menu, the easiest thing I can tell you to do, just hit second, and the button right next to it says mode, but the second function there is quit. So if you get stuck in a screen, you want to go back to the main screen, just hit second, and then the button right next to it, that'll take you back to the main screen if you want to do it by hand. And then I'm just going to come over here on the graph and just, this is not going to be perfect, just do your best to kind of estimate where the point would fall. The y-axis goes by tens, the x-axis goes by ones. So like at -2, if I'm up at like 144, you know, just this is the best you can. It doesn't have to be perfect. So I did like -2, -1, 0. Is that what you mean? Oh, that's what I wrote. Sorry, no, I did write it too. 1, 2, 3, 4. Sorry. No, my fault. I was like, what are you talking about? I'm not paying attention. Sorry. If I do like -1's at 72, so just kind of estimate. 0 is at 36. 2 is, or no, 1 is at 18. 2's at 9. And then they're going to get really close to the x-axis, but they're never going to touch it, never going to go over it. So sometimes I just use my highlighter or whatever to make sure I don't go over the x-axis here. And this is going to form, like I said, this will be kind of like a backwards looking J shape. All right, so just try your best, like get really close to the x-axis, but make sure it does not go over the x-axis when you sketch the graph. It doesn't have to be perfect. Does anybody know the actual equation of the x-axis? Like, what is the equation of this line that I just highlighted? Does anybody know? Which one is it? It is good. The actual equation of the x-axis, which is super weird, is y equals 0, right? Because all the y coordinates are 0, so people kind of confuse that. But anytime you have a horizontal line, I call it horizontal, all the y coordinates are the same. The x coordinates change as you go back and forth. Every single problem you will see today on the notes and the homework have that same asymptote. Now, domain, I promise, the same for every single one. -infinity to infinity, or if you want to just write all real numbers. It still goes left and right forever, even though it's kind of flipped over from what we just did. The range here is actually the same as the one we looked at above too. You don't touch any part of the graph till you hop over the x-axis, so that's going to go 0, and then it goes up forever to infinity. You do not use a bracket because you don't actually touch 0 or go over it, so it's just a little parenthesis. Okay, is anybody having a question at the moment? Now, I'm just going to have, and I will come help you if you have trouble with your calculator at all, but I'm just going to have you guys see if you can make tables for these. Every single graph on here should have, sorry, I think I made these graphs a little too big. I'm just going to zoom out so you can see it. Every single one of these should have the x-axis being the asymptote. Every single one. And so every single one, y equals 0 is your asymptote. Every single one of these, the domain is going to be all real numbers. It's going to go left and right forever. And then the range we'll just have to think about for a second. But I promise every single question today, asymptote will be y equals 0. The domain will be -infinity to infinity. And that domain will be the same when we do some shifting tomorrow, but the asymptote can change. Okay, now I'm just going to walk you through one more time, and then I will come help if you have a question about how to get to anything on the calculator. So it's going to ask you in the directions, plot 5 points. The best 5 points I can tell you to do, let me do -2, -1, 0, 1, 2. We don't have any shifting today. That's probably the best table that you could make. Okay, now once you do that, if you want to do it by hand, plug those numbers into the equation, go for it. If you want to use the table on the graphing calculator to make it go a little faster, you just hit y equals, just maybe clear out, or you can type over what you just had. Now this one is 4 times 1/2 to the x. And if anybody needs help typing that in, I will come help you here in a second. Once you get that typed in, just hit second graph, and that will give you a table. And you can just use the little arrow keys to scroll up and down. And I'm just going to jot the table values down here for what I wrote down. And again, if you want to use that to get yourself some more points, you can do that as well. And when you come over to the graph, just do your best to just, actually these, I think most of these are on nice points. If it's a decimal though, just go ahead and estimate what it would be. And like if I'm at 3, I'm at a half. It just gets really close to the x-axis. Never touches it, never goes over it. So do not draw it over the x-axis. And then the range for that one's the same as what we just did. You don't touch the graph, come from the bottom to the top. You don't touch the graph till you hop over the x-axis. So 0, and then it goes up forever. You guys try that next one. I'll come around and see. If anybody's having trouble with the calculator or it's not giving you what you want, I will come help you with that. Okay, for your exponent, you can just switch from the button there and check it. Okay. Alright. While you guys are, I'm just going to do this real quick on mine. For the graph right next to this. Alright, so if you use that same table, which would be a good recommendation, tomorrow we might move it around a little bit. My voice keeps cracking. Okay, -2 should be about 0.75, -1's 1.5, 0 is 3, 1 is 6, and 2 is 12. And then it starts getting really big really quick. So if I'm just kind of like guesstimating here, just to the best I can, doesn't have to be perfect if it's a decimal. If it's on a nice point, that's great, but if it's not, just do your best to kind of estimate. So your general shape, you can get real close to that x-axis, but never touch it, never go over it. And should also be the same range as the one right next to it, from 0 to infinity, because you're not touching any part of the graph till you hop over that x-axis, then it goes up forever. Okay. Now, we're going to do these two at the bottom, but I promise this is going to go super fast. All right. If you guys look at the two equations, let me make this a little bit bigger here. At the top, I have 4 times 1/2 to the x here, 3 times 2 to the x. Down here, it's almost identical, but I made the a value negative. So this is -4 times 1/2 to the x, and negative 3 times 2 to the x. Both of these graphs that are down at the bottom of the page would fall into that category as being neither growth or decay, because the a value is negative. That's what it says right there, graphing exponential functions, a is less than 0. That just means the a value is negative. So this would not be growth or decay. So if these equations are identical, except for a little negative out in front, does anybody know how that would, like, what would I do to this graph if I just put a negative? Like, what would it do to the graph we just did above? How would the negative affect it? Does anybody know? It flips it, that's it, literally. Like, okay, so negative in front of the equation like that is called a reflection over the x-axis. I'm literally just going to take this and flip it upside down. Same thing, this is identical equation, except this is negative, this is not. It's just going to flip it over. So if you guys are doing your table, the table would be identical, except for the y values are just going to be negative. So my pen is going to die on me right now. Okay, negative 2, negative 1, 0, 1, 2. Instead of being positive 16, it's going to be negative 16, negative 8, negative 4, negative 2, negative 1. All it's going to do is just go flip it over. I can copy the table from the 3 times 2 to the x, negative 3 times 2 to the x. Same x values. The y values are going to be identical. They're just going to have a negative in front of them. It's just going to flip it right over the x-axis. All the numbers would be the same, just negative. That's the only difference. And let me make that a little bigger so we can actually read it. So when you plot them, it's just going to take that shape and flip it exactly, just a reflection over the x-axis. So negative 2, negative 16, negative 1, negative 8, 0, negative 4, 1, negative 2, 2, negative 1. And again, this is going to get really close to the x-axis, but it is not going to touch it, not going to go over it. So make sure you don't draw over the x-axis, just kind of curve that. It's going to get really close to it, never touch it, never go over it. If you plot the other graph, it's the same, it's just going to be turned in a different direction. So I'm just doing my best to estimate each one of these. And again, it's going to get really close to the x-axis, never touch it, never go over it. Oh, sorry, I'm not on the screen there. Now, let me ask you guys about the range. Here, I'm going to move this up so I can see this a little bit more. Okay, what would you guys tell me for the range for these two graphs? They're actually both the same. It's different than all the other questions that we've done today because these flip upside down. Yes, so this points down forever. So negative infinity, it would be the lowest value, and it actually stops when you get to the x-axis. So if your graph is turned upside down, you want to go negative infinity and then stop at the asymptote. So today that should be 0 for all these questions. So negative infinity stops at your asymptote. Again, I have parentheses around that 0 because you don't actually touch it, you don't actually go over it. That's all we're working on today.